Hello everyone, welcome to my class. In today's class I am going to cover unit circles and trigonometry of real number. So let me start the class right away. First, the definition of unit circle. The unit circle is defined as a central circle with radius 1. So that is the circle center at origin and radius 1. The equation of unit circle is x square plus y square equals to 1. Here 1 is radius, so radius is square. We can locate points on the unit circle using symmetry. So on the diagram here, the unit circle is symmetric about x-axis as well as about y-axis, and there are 4 quadrants. The Q1 is the first quadrant. This is Q2, second quadrant. This is Q3, third quadrant. And this is Q4, that means fourth quadrant. So if we pick a point, let's say XY in the first quadrant, then in the second quadrant, our X coordinate becomes negative. And in the third quadrant, both of our X and Y coordinate becomes negative. And in the fourth quadrant, the y coordinate becomes negative. So now example 1. Find x if the point is x comma radical 5 over 4 lies in the unit circle in first quadrant. So solutions, let's substitute x value and y value on the equation of circle here. So x square plus this is y value, radical 5 over 4 square equals to 1. Then simplify, here is x square as it is, 1 as it is, square radical 5 and square this cancels, and here 4 square is 16, so 5 over 16. Bring this number to the right side by subtracting, so here is minus 5 over 16. Simplify these two fractions. This is 1 minus 5 over 16. Take LCD is 16, so multiply 1 on numerator and denominator by 16. So then 16 minus 5 over 16, which is 11 over 16. And in the first quadrant, x coordinate is positive, so x equals to radical 11 over radical 16, which is 4. So we found x equals to radical 11 over 4, the coordinate for x. Great. And by symmetry, other 3 points on the unit circles are, now here is x negative, that means negative radical 11 over 4 comma radical 5 over 4. And in third quadrant, both x and y are negative, so we found this point here. Similarly, we found point on fourth quadrant also, where y coordinate is negative. I hope this computation makes sense to you all. Now let's move on. Special right triangles and the unit circles. 2 special right triangles we discussed in our earlier sections. So one is 45, 45, 90. The size of the triangles ratios is 1 to radical 2, and another one is 30, 60, 90 triangles, where the sides ratios are 1 to radical 3 to 2. In the diagram here, 45, 45, 90, 1 to radical 2. And next diagram is 30, 60, 90. Sides are 1, radical 3 and 2. Next, let's rescale them by the hypotenuse. Means let's divide by radical 2 on the ratio of the side here. So we have 1 over here radical 2, 1 over radical 2, and then 1. And in the second diagram again, we are rescaling by 2, means dividing by 2 on the ratio of the sides here. So we have 1 over 2, radical 3 over 2, and 1. So in the shape wise, we have a smaller shape here. I hope this idea makes sense to you all. So now here the hypotenuse corresponds to the unit circle's radius. So then this first two let's make up a point out of these two numbers. That means the point 1 over radical 2 comma 1 over radical 2 and another point 1 over 2 comma radical 3 over 2. Those points lie on the unit circle. Awesome. So then remark, three important numbers you should remember are those numbers that we discussed here: 1 over radical 2, 1 over 2 and radical 3 over 2. These numbers form an order pairs in the first quadrant of the unit circle. So let me talk about this diagram here. So we have a unit circle, and this point here at pi over 6 is radical 3 over 2 comma 1 over 2. The point at pi over 4 is 1 over radical 2, 1 over radical 2. The point at angle pi over 3 is 1 over 2 comma radical 3 over 2. So that means here from origin this distance is 1 over 2, this distance is radical 2 over 2 and this distance is radical 3 over 2. So here on my numerator I have radical 1, radical 2, radical 3 and denominators 2, 2, 2. And on my along y-axis here we have radical 3, radical 2, radical 1 and on our denominator we have 2, 2, 2. So if you remember this order here correctly, then it's easier later for you to remember the value of trigonometric functions. So this side is 1, 2, 3 under the radicals, and this side is 1, 2, 3 under the radical. Awesome. By the way, in decimal form, this is 1/2 is 0.5, 1 over radical 2 is approximately 0.7 and radical 3 over 2 approximately 0.866. Great. So now let's move on. Trigonometric functions and points on the unit circle. The 6 trigonometric functions are defined in terms of a point on the unit circle based on the special right triangles. The special right triangle we discussed earlier, and the central angle theta as follows. So here this is the unit circle, and let's say point is here pxy, and radius is 1, the angle is theta here. Then so here if you draw a perpendicular from P on the x-axis, then this height is simply y and this height is simply x. Y corresponds to sine theta and x corresponds to cosine theta. Then the sine function is, we write as sine theta equals to perpendicular over hypotenuse. Perpendicular is sine theta, hypotenuse is 1, so simply sine theta, which is y. I hope this makes sense to you all. Similarly, cosine functions, cosine theta turns out to be x. The tangent functions, we know the tangent functions is sine functions over cosine functions, so that means y over x. Similarly, cosecant functions 1 over y, secant functions 1 over x, cotangent functions x over y, that is cosine theta over sine theta. I hope this definitions of trigonometric functions make sense to you all. Now let's move on. Quick alert. Remember, there is no such thing as sine, cosine and tangent. They must carry an angle. Now special angles. Next, special angles. If theta turns out to be 30 degree, 45 degree and 60 degree, then we do have this sides value here. So the perpendicular turns out to be 1. If this angle of reference is 30 degree, then the perpendicular turns out to be 1, hypotenuse 2 and base is radical 3. And similarly for the case of 45 degree and 60 degree. Great. So then here sine 30 turns out to be perpendicular over hypotenuse, so 1/2. Sine 45 turns out to be again perpendicular over hypotenuse, so 1 over radical 2. and sine 60 turns out to be radical 3 over 2. Similarly, cosine 30 turns out to be radical 3 over 2. Cosine 45 turns out to be 1 over radical 2 or radical 2 over 2. Cosine 60 turns out to be 1 over 2. Summary: below is a full list of values of trig functions at various angles. So here you do need to remember this table or this diagram. Let me talk about this table here. The first column, angle. Second column, the value of sine theta, then cosine theta, then tan theta, and then cosecant theta, then secant theta, then cotangent theta. So first, for the sine on 30 degree is a 1 over 2, then 45 degree is 1 over radical 2, 60 degree root 3 over 2, and sine 90 degree is 1. Then we reverse those values for the cosine in reverse order. So here cosine 0 is this one, and cosine 30 is this sine 60, this one, and cosine 45 is same as sine 45, and cosine 60 is this sine 30, and cosine 90 is this sine 0. Then we have the value of the sine and cosine in the first quadrant, and then we use our definitions to find the value of tangent, cosecant, secant, and cotangent theta. For example, for the tangent theta, we divide sine theta by cosine theta. That means 0 divided by 1 is 0. And then tangent 30 degree is sine 30 divided by cosine 30. So 1/2 divided by radical 3 over 2 turns out to be 1 over radical 3. And so on. And so on. I hope this chart makes sense to you all. So please, you need to remember the values of the trigonometric functions, this table. And I only gave you this table for theta up to 180 degree, and we can easily compute up to 360 degrees and beyond. So here we use the symmetricity. So that means here 30 degree, this value is same as at 5 pi over 6, but here's our x coordinate is negative, so then here the coordinate is minus radical 3 over 2 and 1/2 here, and then we can find easily at 7 pi over 6, both coordinates negative, and similarly you can find the value at 11 pi over 6, just making y coordinate negative, and so on. Great. And so in this diagram here, in the first quadrant, all trigonometric functions are positive. In the second quadrant, sine and cosecant are positive. And in third quadrant, tangent and cotangent are positive. And in fourth quadrant, cosine and secant are positive. So in short, we say all students take calculus. A means all trig function, S means sine trig functions, T means tangent trig functions, and C means cosine trig functions. I hope this makes sense to you all. Now let's move on. Remark: the quadrantal angles are the angles those lies on the axis, x-axis and y-axis. So one is 0 degree, one is pi over 2, which is in decimal form 1.57, angle pi, which is 3.14, this is approximately, and 3 pi over 2 approximately 4.71, 2 pi approximately 6.28. Great. Now next, let's talk about trigonometric functions of real number. If t is a real number and p is a point on the unit circle that corresponds to an angle of t, then cosine t is x. So now here in this diagram, this is the unit circle, the point is here, then this x corresponds to the cosine of this angle t, and y corresponds to the sine of this angle t. Then we can easily define other remaining trigonometric functions. Here tan t is sine t over cosine t, cosecant t is 1 over sine t, secant t is 1 over cosine t, and cotangent t is 1 over tangent t. Awesome. Note, for any real number t, still the Pythagorean theorem satisfies here, which is cosine square t plus sine square t turns out to be 1. The domain of both sine and cosine functions is all real numbers, and the range is at least -1 to at most +1, because these are the functions in the unit circle. Great. Now next, let's talk about reference angle. This is the acute angle formed by the terminal side of a given angle and the x-axis. So for the t in second and third quadrant, our reference angle equals to the absolute value of pi minus t, and for t in fourth quadrant, the reference angle is 2 pi minus t. I hope this makes sense to you all. Now, example 2. The given point P with coordinate -2/5 and radical 21 over 5 be a point on the unit circle. Find all the values of all 6 trigonometric functions. Great. Let's begin the solutions. So here, this x coordinate corresponds to cosine t, which is here, and y coordinate corresponds to sine t. So now we have, this is cosine t, this is sine t. Then we can easily compute tan t. That means divide this number here. So we have minus radical 21 over 2, because 5 cancels. Similarly, cosecant t is just a reciprocal of sine t. So you just flip it, 5 over radical 21. Next, secant t is just a reciprocal of cosine t. Just flip it, minus 5f. And the cotangent t is just a reciprocal of tangent t. Just flip it, minus 2 over radical 21. Oh, equal sign here, equal minus 2 over radical 21. Great. I hope this makes sense to you all. So now let's move on. Quick aside. If Q is a point with coordinate -2, radical 21 is any point, this is not on the unit circle, then first find the r. That's the distance of this point Q from the origin, which is under the radical, the first coordinate square plus second coordinate square, here which turns out to be 5. Then divide its coordinate by 5. Then it turns out that that point lies in the unit circle. It lies in the unit circle. Great. I hope this idea makes sense to you all. Example 3. Find cos t if sine t is radical 3 over 2 for t in second quadrant. So we have given the value of sine t. So let's use Pythagorean identity. We know cosine square t plus sine square t equals to 1. So then cosine square t as it is. Then 1 minus, let's put the value of sine t. Sine t is radical 3 over 2. So sine square t means radical 3 over 2 is square. Take this number to the right side by subtracting. So in the next step, 1 as it is. This radical and square cancels in the numerator, and in the denominator simply multiply 2 times, which is 4. So we have 1 minus 3/4, which is 1/4. So then take both sides the square root. That means cosine t equals to plus minus 1 over 2. Awesome. Since our angle t lies in second quadrant, the x value should be negative. So is the cosine t. Hence, cosine t equals to negative 1 over 2. So there's a type here. We do need to put minus sign here. So minus 1/2. I hope this makes sense to you all. Great. So now let's move on. Example 4. Find the reference angle associated with 5 pi over 4 and the point P on the unit circle. To begin the solutions. here the terminal side of the angle is a 5 pi over 4, which is in degree 225 degree, which lies in third quadrant. Thus our reference angle equals to then 5 pi over 4 minus pi, which is simply pi fourth. Next, let's find the cosine and sine of the reference angle. Then cosine of pi over 4 equals to 1 over radical 2, which is sine, again sine theta or sine pi over 4. But the given angle is in third quadrant. So in the third quadrant, both sine and cosine are negative. Just remember, all students take calculus. All means first quadrant, student S, which is sine in second quadrant, these are positive, and take T in third quadrant means tangent positive in third quadrant, and in fourth quadrant cosine is positive. So in third quadrant only tangent positive, that means sine and cosine should be negative. That means both x and y coordinate are negative, so we pick our point is negative 1 over radical 2 comma negative 1 over radical 2. I hope this idea makes sense to you all. Now let's move on. Example 5. We have the given point with coordinate 3/4 comma negative 4/5. This is the point on the unit circle that corresponds to the angle T. Then find the coordinates of the point corresponding to the angle negative T. Awesome. So let's begin the solutions here. X equals to, that's cosine T, which is 3/4, which is positive, and y equals to sine T, which is negative 4/5, which is negative. Now x positive, y negative. That means the point x comma y lies in fourth quadrant. That means the angle T lies in fourth quadrant. So the corresponding point is then in fourth quadrant, y coordinate is negative, so that negative and that negative is positive. So then our point is P, whose coordinates are 3/4 comma 4/5. I hope this makes sense to you all. We finished this sections 5.2. Thank you.